Hello there, good people. My name is Marco. Welcome to my channel. Today I'm gonna go on with the Python's project for beginners, and today I'm number 4, which is dice rolling. Yeah, dice rolling. I know. Yeah. Well, the project in itself is pretty self-explanatory. I mean, you just write a script that simulate the roll of a dice. But towards the end, I will try to implement something a little bit more advanced, a little bit more difficult. And to be honest, in my own experience as a self-taught programmer, I can tell you that probably the skill, the ability to improve these small little projects is probably very important for anybody who's learning programming. Because after all, if you think about it, sometimes you start from something very small project, a very easy project, but then adding a little bit more creativity and something that is increasingly difficult, you can end up with something that is completely different from where you started, and sometimes it is a well-rounded project and you might have learned many things from it. But anyway, let's get on with the project, okay? So right now I can open the terminal and I can create the file, and I will name it dice rolling.py. So it should be here. Yeah, there it is. Nope. Okay, I'll try to make sure to zoom in this time. That should be good. Okay, so the first thing I want to do, of course, is try to go on with what I did last time, so implementing classes and in a sort of a object-oriented kind of way. So I think I'm going to create classes as well this time. So first of all, we need something to simulate a dice, and the dice is basically something that has 6 faces or any number of faces, and pick random numbers between random numbers in a range, which depend on a number of faces. So the first module I need is probably the random module. This is the most important one. After importing the random module, I can start creating my class. And the first class I want to create is actually dice. And the dice is, well, it's pretty simple if we look at it. How can I init it? Well, I can say a number of faces, because dices are not always have 6 faces. So the faces equal faces. Okay, and then I will provide a method which is called roll, and this method will actually return return an integer. So the randint function works like the a, in this case is the start of the range, which is 1. In the end, I can say self.faces. So if my dice is normal, has 6 faces, I will have a random integer between 1 and 6. And 6 is included in this case. Okay. We can actually try and run it now. So I just create the dice object, and I put 6 faces if I want to. Then I just say print out dice.roll, and let's see what comes out. Try and run it, and okay, let's see if I can zoom in. Yes, 1. Well, that's good. 2, 5. Well, it's pretty much done, I'd say, right? Just joking. This could be like the beginning of something. So let's try to put a bit of creativity behind this. So what can I do with this class? Well, I can try and implement a game, for example, because some games have multiple dices. So you don't have to throw once or one dice alone, but you can actually have multiple dices. And to do that, I want to create a class of game. Why not? So in this class, the init method would be very simple. So first of all, I want the number of dices. And secondly, I want the number of faces of the dice. And as always, self.dices equal dices, self.faces equal faces. Now that I have the init method, I want to create the dices object. I will provide a method which is create dice. I put the underscore in front of it, and this is supposed to mean in the Python kind of standard that this is meant as a private method. So it's not meant to be used outside the class, and it doesn't make it private, but it indicates that it is a private method. You could use that for variables as well. So if a variable is not meant to be used and seen by the user, you just put an underscore and it should give that idea. What does the create dice method does? Well, we can say a bit of a flow control. So if there are no faces, I can just return a string, like a message. You can't play with no dice. Actually, let's say dice is better. So if the input is 0, there is no dice, so I'm not even gonna bother creating it, you know? But if it's not 0, well then I just need a range like this. Dices, and I'm gonna create a dice object for each one of the input, and they will have the number of faces that I provided in the init method. And what I can do in a class is actually create kind of a global variable, which is I can call it all dices. I'm gonna init it like this, like an empty list. And every time I create one object, I just append to it. So you should call it like this. And I'm gonna append the newly born dice. Okay, so that's pretty much it for this method. So what this does is basically it creates the dice. One other thing is the actual game, where I can say play. And what play can do is actually, well, first of all, it creates the dice. So it uses the private method like this. Then what I want to do is actually when I throw a dice, I want to return the number on that dice. And if there are multiple dices, I want to return the sum of those dices. So what I can do is just output equals 0. And this loop will go into the list that contains all the dice objects. And for each element in this one, I will basically throw it. So it's i.roll. And I can do that because it's a dice object. And this throw will be sum to the output. That's pretty much it. Okay, so I want to try this new one. Let's try to create a game. Call it game. So we name the number of dices. Let's put 3. The number of faces. Let's put 6. Now that we have the game, I want to print out the actual result. So I just say play, and let's see what comes out of it. None, of course, because I'm not returning anything. In the end, I need to return output. Let's try again. It's 7. Oh, it's working. Okay, 6, 8. Okay, it's working. With 3 dices, it's a not very high number, but it's working. One other thing that I can do in this case is actually certain games work like this. If you have a pair when you throw a dice, you throw again. So I might need to see each individual dice, like what is the number of each individual dice. And to do that, I want to do it sort of a log system. So I just provide a throw log, and I'm gonna init an empty dictionary. The easy thing to do now is to provide a way to kind of name the elements in the dictionary. And I can just say, I provide a counter. Every time I throw the dice, I increase the output, I increase the counter, And then I can put the result in the actual throw log. It should be self because it's a element of the class. And in here, the key for this result could be a string like dice, and you can just put counter. So the first dice would be dice number 1, and then I want to see what dice number 1, what the number in dice number 1 was, and so this should be the throw. At the end of everything, I actually want to print the throw log. So like this, I can actually see the number each dice yielded. Let's try again. Let's try and see it. Okay, so this time I got 10. Dice 1 was 3, 3 and 4. So I got a pair. Well, let's try and play with 2. Let's see if I get a pair. 3 and 4, 5 and 3. Like this. This is an example, and I can throw again if it ever happens. Fantastic. Now, it works. So I was able to simulate the roll of a dice. Now, let's start to add something, just a little bit, in the intermediate kind of ways. So let's go back to the project and see how we can do that. One thing that I can do is actually simulate multiple throws. So not just one, but I can create a script so that every time I can just say, throw the dice 100 times or throw the dice 1,000 times, and then give me the result. So how many times 6 came out? How many times 3 came out? And with that, we might, do something interesting. This method would be outside the class, and I want to call it log dice throws. And it takes in a number of throws, let's say. Yeah, like this. Okay, all right. So as always, a little bit of flow control. So if throws is equal to 0, return 0. So basically, if you never throw it, you just return what it is without even computing. Now I create the dice object, and it's a dice with 6 faces because I like it. And I'm gonna initialize an empty dictionary, and this is gonna be my dice count. My dice count. So now I just have to create a loop, have my dice rolling, and every time I'm just gonna keep track of each number that comes out. So what I can do is and what I do now is something that is very useful when dealing with the dictionaries, and it's very useful when you want to create something that counts certain objects. So what I have is an empty dictionary. So now I'm just gonna say that the dice count, and we can call it throw, either 6, 3, 2, etc., etc. This is gonna be my key, is actually equal to dice count dot get. And get is used to basically find a key, find a value inside a dictionary. But what it does also, it takes in 2 arguments. The first one is the element that it needs to find, which in this case is throw. The second value that takes in is actually the default value. So try to get this. If you don't find it, you put this value. So if you don't find it, it means that it's going to be the first time that that number comes out. So just put 0. Why? Because then I just say +1. And what this does is basically, let's say that 3 has come out 5 times. He's going to get it. It's going to be 5. And then it's going to add 1. So it's 6. So it's the 6th time that 3 comes out. This is basically everything I need to do. Now I can return the dice count. Now we can actually try and run it and see if it works. It's pretty simple. I just need to print log dice. throws, and I'm gonna put in 100 throws. Let's see what comes out. Alright, so the result is actually pretty fair. So it's 1 16 times, 6 20, 3 13, etc, etc, etc. This is the output I was actually expecting. Now, how can I know whether this dice is biased or not? I mean, these numbers are valid or not? Of course, it exploits the randint methods, so it all depends from the random library. So it is up to the random module to determine the real randomness of these numbers. However, we could actually find a way, just to make it a little bit more interesting, we could find a way to see if the dice is actually biased or not. But for this, I really need the help of a professor. So let's hear what he has to say. Hello there, I am Professor Mario from Mario, and today I want to talk to you about uniform distribution, what it is, and how we can use tests to verify the validity of uniformly distributed data. Uniform distribution is a type of data distribution that happens for those events where each single outcome has the same probability. The best example might be the seconds in a minute. What are the odds that now is 23 seconds past a full minute? The answer is very simple, 1 in 60. And it will always be like this no matter when I ask the question. And above all, each second in a minute has 1/60th of a chance to be the current second on the clock. When we deal with uniform distribution, there are a few tests that we can do to demonstrate the validity of the data. One of the most common and probably easier to understand is the chi-square test. Chi stands for the Greek letter that looks like an X, namely chi. Via the test, we can run what is called a dependency test, and as the name suggests, it hints to either the dependency or non-dependency of the results. We start with a null hypothesis, which says the results are not dependent to each other. For the example of the seconds, it holds true, because finding 23 seconds isn't affected by the previous reading, nor by the next, and there is no variable that might change the probability. A dice is another perfect example. Each throw should be independent from the previous one. Just because a 6 came out doesn't lower the chance that a new roll might give 6 again. With this dependency test, we can then find out whether the dice is in fact clean and the results are independent, or the dice is altered and therefore not reliable. Hence, we can reject a null hypothesis. Thank you for listening. Yeah, thanks, Professor. Absolutely, yeah. So, we get it, okay? Alright, so what I want to try and develop, and this is kind of advanced, but I'll try to keep it simple. I want to try and develop this chi-square test. Okay, what I want to do is to create a method which takes in a couple of arguments. The essential things for the test are the expected value, which is basically the number that I expect, and in the case of the dice, I always expect 1/6. So if I throw the dice 100 times, I will expect 100 on 6, which is 16 or so, 16 and something. Then I want to measure the difference via the formula. And this difference tells me how far is the number from the expected value. And it's squared, so it's always going to be positive. Once I get every difference for each of the possible outcome of the dice, I just need to sum them all up. That is going to be my chi-squared value. So let's do that first. Okay, now that we're done, let's start with the 100 throws. Now we write the log right here, we feed it to the test, and we should see the result. Let's try and run it. And boom, chi-squared is this number, 10.16. Let's try again, for good measure, 6.8. Okay, but what does this mean? Well, basically nothing, because the real test comes from the so-called p-value. This value helps interpreting the data coming from the dice. To be read correctly, the p-value needs to be accompanied by the so-called alpha value, or also called the significance level. That is commonly set to 0.05. This indicates the boundary between something that is statistically significant, that was hard, and something that is not. In this case, 0.05 translates to 5%, and as many things in statistics, it works in reverse. So if my p-value is smaller than the alpha value, it means that I have a 95% certainty that my data, my dice, is biased. Namely, the statistical anomaly is significant and shows a trend that is not independent. To put it simply, the test failed and you should just throw the dice away. Let's implement this in the script. How could I know the p-value? In Python, you can install a module which is called SciPy, and in that module there is a library called stats. So we can import that from SciPy. Import stats. FYI, in the stats package there already is a chi-squared method if you didn't want to implement it yourself. In the package we can find a way to calculate the p-value just by inserting the result of the chi-squared test and the degrees of freedom. It is not important what they are. Usually you can find them by taking the number of possible cases. For the dice 6 and then just -1. So for our case, the degrees of freedom is just 5. Okay, now that we know this, let's finish the script. What I did is setting the basis for the test. So if the p-value is smaller than the alpha value, the test fails. The dice is biased. Whereas if it's greater than, then the test succeeded. The dice is safe. Let's try and run this. As you can see, our dice is perfectly safe, of course. Okay, I'd say this is all for this video. Thank you very much for watching, and again, I encourage you to experiment with these things. Try not to skip beginners projects or any project, because especially for self-taught programmers like myself, for example, the key to learn is yourself. So the ability to work around a project, improve it and implement new features, it's something that will enhance your learning experience 100-fold. It's definitely something that you won't regret doing. As always, if you enjoyed the content, please leave a like and subscribe. And if you have any new ideas for new projects, don't forget to comment down below. Thank you very much, and I'll see you to the next one. Bye bye.